Alright guys, so in this video I'm going to show you a workflow for setting up a simulation of some large tall tunnel waves using the Phoenix Wave Force. And I'm also going to show you some new stuff that we added in the Phoenix Wave Force in the nightlist of after Phoenix 4.3. So let's start from the very beginning, and I'm going to explain to you what is the Wave Force and why do you need it. So in the very beginning, let me set up my units. So this is very important before you begin. I'm going to use meters, and I'm going to use 0.1 meters as a unit. So this is 10 centimeters. I want it to be a bit on the high side so I can get a more large scale epic simulation. So I'm going to create a long container like this. Here I'm going to show you that I'm using Phoenix 4.3 nightly. It's a build from the 11th of November. Okay, and let me start by enabling initial fill-up and starting the simulation. So this is the Phoenix Ocean container, and inside it you can have vessels floating, or you can have geometries splashing inside the container, or geometries flying out of it. And all of these, they will interact with the fluid and create some ripples and create some splashes and interesting effects. And on top of these, you can add some ocean waves. So there are two ways to do that. You could enable the Phoenix render time displacement. Right here you can plug any texture, but in this case I'm going to use the Phoenix ocean texture. Okay. And let me show you the mesh. You can see the effect of the ocean displacement both on the mesh preview and on the particle preview. So this is a render time effect. So you can only see it while rendering. You can see it in the preview, but the actual simulation solver, it does not know about it. So what the solver sees is just this, a flat liquid surface. So for example, if we look at it from an angle, we can see that there are some slight disturbances here and there because there is some fluid simulation going on, but overall it's smooth. So this is what the solver actually sees. So the displacement is just a render time effect, and these waves, they cannot interact with your geometries in any way. They will blend with your simulation, and you can control that using these options here, but they cannot interact with the geometries that you put inside of the simulator, like real fluid. So in order to do that, I have to create a Phoenix Wave Force. So the Phoenix Wave Force would create some real simulated waves inside the simulator. And unlike the displacement, right here I can plug only one kind of map, and it is the Phoenix Ocean texture. So in this case I'm going to reuse the one that I already created for the displacement, but it's not a problem to use a different one. So you can combine both approaches. You can have both displacement and a wave force, or just displacement, or just a wave force. Okay, so let me start the simulator again. And now we can see that something starts to happen. So I'm going to disable the mesh preview. And here in the particle preview, you can see that by default, the liquid particles, they are colored blue, and their color is scaled by the speed of the particles. So you can see that the wave force starts adding some velocities to the particles. If I enable the mesh preview again, we can see that we're getting these tiny waves starting to appear. And these are the real simulated waves. They will interact with your geometry. So if you want some more complex interaction, this is the way that you should go. Okay, so these waves are kind of underwhelming. So let me increase the strength of the wave force to 5. So with the old Phoenix wave force, before the stuff that I'm going to show you later in this video, you often had to increase the strength to some larger number, like 5 or 10, in order to get a more visible, stronger result. Okay, so here it is. And now, how to turn this simulation into a large tunnel wave? So there are two approaches to it. So I can start changing some option changing the options of the wave force, changing the options of the ocean texture, which are very important. All of these options are very important to the way the wave force works. And I can start changing them and see what happens. But in order to be able to control better what is actually happening, I'm going to show you something else. So Phoenix has this option here. It's called Pure Ocean. So in order to enable it, I have to switch from mesh mode to one of the ocean modes, like cap mesh or the ocean mesh. So I'm going to use cap mesh because in ocean mode, the entire viewport is going to be meshed, but in cap mesh, I'm going to only have the surface of the liquid simulator. So now I'm able to enable Pure Ocean, and Pure Ocean mode, it does not need any simulated caches. So let me turn off the particle preview entirely. And so this mode, actually it ignores the caches from the simulation. It just creates a flat surface. So when you enable displacement, you will see the actual ocean waves shown right here in the viewport. So you can see that I can go to the end of the timeline and there are no caches there whatsoever. I can even delete them from the toolbar. And it would allow me to preview what the Phoenix ocean texture is actually doing. So this is a preview of the ocean texture as a displacement, and this is the texture that is actually driving our wave force. So of course, in the simulation that we already did, the waves were a bit taller because I increased the strength of the wave force, and they were even starting to break, which is good because we want that fluid effect to also happen. And so later in the video, I'm going to show you how you can balance between how accurately the liquid follows the wave force and how much freedom it's actually allowed to have. So in order to transition from these kind of waves into the large tunnel wave that I want to get, let me first change the velocity coherence option. So this controls the direction in which the waves are moving. So when you get more coherent waves, I can start changing it and we can see it directly in the viewport. Okay, so I can make all of the waves move in just one single direction when I change the velocity coherence to 1. On the other hand, if I lower it down to 0, then we get all kinds of waves moving in all different directions. So the waves are crossing one another in all directions, but in order to get a large tunnel wave, I'm going to increase this to 1. So before I start the simulation, I want to be able to actually view this and the actual simulation. So one way is to just, now you can see that the wave force is starting to affect the simulator. So I can enable displacement, enable Pure Ocean, check how the ocean texture works, and then disable both and check how the simulated waves work. But this is a bit tedious, so I'm just going to copy the simulator right here and use the copy to preview the Pure Ocean. So I'm going to enable Pure Ocean on the copy, enable displacement, and in order to make sure that this simulator does not actually simulate any caches, I'm going to delete the output path, and in order to make sure that it doesn't load any caches, I'm going to delete the input path just in order to avoid any mistakes. Alright, so now if I scroll the timeline, you can see that we get both the simulated waves and the displaced Pure Ocean. But if I go back to the original simulator, enable Pure Ocean and enable displacement, now we can see that these waves are actually not the same ones as the waves here. So I have to go and make a couple of adjustments. So the first thing would be that after I created the second simulator, after I copied it, 3ds Max copied the ocean texture that was plugged into the displacement as well. So I'm going to pick the second simulator and just plug this into its displacement slot. This way we can have just one ocean texture, so that there won't be any mistakes. I won't be changing the settings of one ocean texture and wondering what's going on. Okay, and so the other thing is that right now we can see that we're getting different waves. So the reason for that is because the Phoenix Ocean texture by default is in world space, so it uses the world XYZ as a source of coordinates. So this means that each of these two simulators is just a window into the infinite Phoenix Ocean. So if, for example, if I grab the second one and if I move it around in the viewport, and if I just change the timeline frame, we can see that we get a different results. So if I move this closer to the first simulator, we can see that the two simulators match. They are just showing two different pieces, two windows inside of this Phoenix Ocean. So in order to get an exact same ocean into both simulators, I'm going to change this from world into object space. So this way each simulator gets its own copy of the Phoenix Ocean, and this allows us to get the same wave inside of both simulators. So now I can go back to the original simulator, turn off pure ocean and turn off the displacement and start the simulation, and this would allow me to compare side by side the ideal pure ocean waves against the simulated Phoenix waves. Okay, so now we can see that the simulated waves are starting to move in one direction. Something else that I can also adjust in the ocean texture would be to increase the wave crest. So when I do this, now you can see that we are starting to get some longer and more straight waves. So all of these smaller waves in the middle, they are starting to get stretched out and removed. So I can increase the wave crest up to 1. And of course, something else that I can do would be to increase the wave height. So now we're getting these small waves. They're kind of not too tall, and the ideal ocean wave is really flat as well. So I'm going to increase the wave height to 5, like this. And then I'm also going to increase the scene scale 10 times. So right now this simulator is 2.6 meters tall. So what I will do right now is to increase the scene scale to 10, and this way, without changing the size of the simulator in the scene, I'm going to cheat the solver into thinking that the simulator is 26 meters tall. So okay, and this would allow me to get some larger and more epic waves in order to get the kind of breaking tunnel wave that I'm after. And something else that I'm going to do is we get a lot of these smaller waves in between. So if I decrease the level of detail, you can see that we are starting to take away these waves from the ideal ocean wave. So if I increase this, we are starting to get more and more of these smaller waves, and I can increase the level of detail a lot. And some of that you will not see in the viewport, but it would show in the rendering, because the Phoenix rendering of the Phoenix Ocean, it allows the ocean to generate detail that is even smaller than a pixel. So such high level of detail, it would matter to rendering, especially if you're using higher resolution. But note that also it does matter for the wave force. So if I'm using an ocean texture with a higher level of detail, the wave force is going to try to recreate all of these smaller waves, and it's going to add a lot of noise to the simulation. So if I decrease the level of detail, I can take those waves away and leave just the more important ones. So if I run the simulation right now, let's see what happens. Also, in order to be able to iterate more quickly, let me just go to the output rollout, and right here I'm going to disable the export of the liquid particles. So this would allow the simulation to run faster. I don't need the liquid particles right now. I only need the mesh preview, and it uses the voxels. So this would allow me to iterate faster and simulate more quickly. And when I'm done setting up the ocean waves, I can enable this back. Alright, so now you can see that after I've increased the scene scale, we are starting to get these tall waves which take a lot of time to subside. So this is what the scene scale does. The simulation becomes slower, so everything inside starts moving more slowly. The gravity needs to do a lot of work in order to have these waves splash and break down back onto the ocean level. Okay, so let me show you the new thing that we've added to the Phoenix Nightlist. So it's called the Massive Wave Force, and this one allows you to gain more control over the way that you set up your ocean simulation. So if I enable it, one important thing is that I can dial the strength back to 0, and so something else that I can do is that the massive wave force, it comes with this parameter here, which controls how much freedom does the simulated fluid actually get. So if I decrease the fluid freedom option to 0 and simulate again, this would mean that the wave force would try to force and strictly make the liquid follow the ideal ocean texture, the pure ocean texture right here, as closely as possible. So this was something that was not possible before with the wave force. The liquid always had some freedom, and it was kind of following the ideal ocean wave, but it was also doing some things of its own. So now you can force the liquid into morphing into this ideal pure ocean shape right here. So in this example, our simulator is quite low res, so it's just 200k voxels. That's way below 1 million voxels, which is ultra low resolution. So the more you increase the resolution, the closer the effect would be, and you can get a much closer result, and you can make these waves look much more alike to the ideal pure ocean. And also another thing is that the more that I increase the scene scale, the better these waves would match the ideal ocean waves. And just the opposite, if I decrease the scene scale, then the gravity would have to do less work in order to pull down these waves and just flatten them. So when the scene scale is low, it would be harder to recreate the ideal ocean shape. But when the scene scale is high, you get these tall waves which take a long time to crash down. Alright, and if I do the opposite, if I increase the fluid freedom to 1, then I'm giving back all that freedom to the liquid particles. So if I start the simulation right now, it would kind of behave like the old wave force before we added the massive wave force. Okay, let's see. So now you can see that these waves are starting to form, and they kind of correspond to the ideal ocean wave. So for example, this one might be coming from this, but also the liquid does its own thing. Now we can see that this taller wave started crashing down. We're starting to see some breaking, and this is the result that I'm after. Okay, and so here it is, and it's splashing a lot, and the waves are moving up and down a lot, but that's not quite the result that I'm looking for. So let me make an animation preview right here. I'm going to just record this, and this is something that you should always start with. So I'm going to check if the speed of the of the ideal ocean wave is right. So you can see that we have that simulator which is 26 meters tall, and the ideal ocean wave, the pure ocean, is moving at this speed, and this speed is way too fast. So waves that are like 10-15 meters tall that would fit into this 26 meter tall simulator, they won't be moving with this high rate. So this is something that you should always start with, otherwise you would be getting a simulation that might start to look good, but in the end you have to redo it all over again from the beginning. So always start by previewing the speed of your ideal ocean. So this is way too fast, and what I'm going to do is reduce the rate of change of the ocean texture right here to 0.5. So now the ocean texture will be moving much slowly. To be precise, twice. It would be twice slower. And let's make another animation preview and see how this looks. So before you start adjusting the settings of the simulation and the settings of the waveforms, you always have to make sure that the speed of the waves and the rate of change is right. So now this looks better, and otherwise you could see that here the waves are changing way too fast and the liquid is trying to catch up, but it cannot do that in time. So let's simulate again and see how this looks. Let me also increase the timeline. I'm going to make it about 400 frames. And now you can see that these waves, they correspond better to the ideal ocean wave, even though we have the freedom option set to 1. But you can clearly see that this one matches this one matches this one, and even this one starts to break more interestingly. Alright, so this is starting to look good, and this is kind of the result that we're after, but it's going to need some more adjustments. By the way, since I'm showing you the settings of the ocean texture, let me show you something else as well. So right now we have the waves coming in from the right and moving to the left. Okay, so what if you want to change the direction that the waves are moving? So the Phoenix ocean texture is just like any other 3ds Max texture, or in Maya it's like any other Maya texture. So right here you can change the angle of rotation around the z-axis, and this allows you to actually rotate the ocean texture. So I can make it, if I rotate it at 180 degrees, it's starting to move in the opposite direction. Or I can rotate it at 90 degrees and make it move this way. Okay, so I will return it back to 0, and also the tiling works. So for example, you can decrease it or you can increase it, and this allows you to stretch or compress the ocean texture. So of course the Phoenix ocean texture, it never does actually tile. It never repeats. It generates different details and different waves infinitely. But the tiling setting here, it allows you to for example stretch it, and if your ocean waves look like this, decreasing the tiling would allow you to space out these waves more and get more distance between them, and allow more stuff to happen before the next wave comes. Okay, so I will return this back to the default, and let's again check how the result of the simulation looks. So again, here it is. We're starting to get some taller waves, and they are breaking down, but I want an even larger wave than that. So let me continue adjusting the Phoenix Ocean texture in order to show you how the different options work and in order for you to get a better feeling of it. So I'm going to double the wind speed. And when I do that, I get this huge wave that is actually way too tall. It overshoots the height of the simulator. So I'm going to reduce the wave height back down to 2. Alright, so here it is. And let me run the simulation again. Now what we've done is to actually increase the scene scale and make the wave just larger, and the base of the wave, you can see that it's much wider. So let me just pause the simulation, and before that we had all of these waves which were tall, but their base was much shorter. So now we want to have one big large wave which has a longer base, and this large wave, it contains a lot of liquid. And now you can see that the simulator that we currently have kind of struggles in order to create that wave. So now you can see that here the ideal ocean wave is starting to go up, but our simulator finds it hard to follow. So one reason for this is because our fluid freedom is set to 1. So if I zero this, let me stop the simulation, dial this down to 0 and start again. So now I'm taking all the freedom away from the liquid particles, and they will start following this ideal ocean wave much better. Alright, so now you can see that we are getting some pretty close results. And again, as I said, as you increase the grid resolution and also as you increase the scene scale, you get much closer results to the pure ocean. Okay, so this works. So why didn't our simulation, when the freedom option was set to 1, why didn't it work? The reason is that we didn't have enough liquid inside the simulator to feed actually this tall wave. Now you can see that here the bottom of the wave actually almost touches the bottom of the simulator. So we need a lot more fluid, we need more liquid inside the simulator in order to be able to form that huge wave. So let me double the height of the simulator. I return all the freedom back to the particles. And let me start the simulation again. Now we have a deeper simulator. We have a lot more liquid to work with. So let's see now. The wave subsides well. Now it starts rising up. And now I'm starting to see something that I really like. So that's it. That's the effect that I've been aiming for. Now we can see this tall, huge wave it's starting to break, but it takes a lot of time. So now again, let me just repeat this again, that we have a simulator which is very low resolution. It's just under 500,000 voxels, so this is very raw, very rough. You can see the mesh is jittering all over the place, but this allows the simulator to run faster, and now we can see that this big wave starts breaking. So that's it. These are the settings that you should be using. So one cool thing about the waveforce is that it works consistently on different resolutions. So now you can increase the resolution and it would force the liquid into doing the same thing on the higher resolution. So you can iterate at the lower resolution and then you will get a pretty close result to the one you are having with more details and with less jittering of the mesh, and it's going to look cooler. So let's go through the important settings to get large tunnel waves again. So first off, you need to use a deep simulator. The wave needs to have a lot of liquid to feed it, so you need to also have high velocity coherence in order to make all the waves move into one direction. So you could have it at 1 or you can have it at 0.9, but it needs to be high. So you can experiment, you can lower this and see what happens. It would be interesting as well. So also we need to have a large simulator scale, so you could cheat it using the scene scale, or you can create a larger simulator in the scene as well. And you should have a lower level of detail for the ocean texture. So I'm going to show you how it works with different levels of detail. So now I'm using a level of detail of 3 in order to eliminate all of these smaller waves that would otherwise cause some noise and disturbance of the waveforce, and they will not allow it to actually do that thing. So now we can see that we have the second wave crashing. Let me just lengthen the timeline even more in order to see what happens. And the final ingredient is that you should have a slow moving pure ocean wave. So the pure ocean should be moving slow enough that the actual simulated waves, the liquid has enough time to catch up with the force that gets applied to it. Okay, so if I stop the simulation now, we can see the result right here. So the liquid starts building up, and we are getting this large wave breaking, and then another one, and that's it. So I have prepared a few scenes to show you some more stuff. So let's first check out the difference in the effect of the level of detail. So now I have again a simulator which is quite deep, and it is quite tall as well. So here you can see that this simulator is 100 meters high. So the waves inside it would be at most 50 meters tall, or lower than that. And here is my ocean texture. So you can see that the settings here are pretty close. The wind speed is a lot higher, the level of detail is 3, but the rate of change is just 1 because the wind speed is so high. So let me show you a comparison. So this is how the simulation works with the level of detail of 3. This is how it works with 6. So now you can see that you're getting a way more of these waves, much more waves, and the simulation is much splashier. And here is the result with 20, with a level of detail of 20. So increasing the level of detail, it creates more disturbance and more waves. So you might want to go after this kind of effect, and in this case you would need more level of detail. But if you want to get a clean single wave, then you should be using lower level of detail. Okay, and let me also show you a comparison of how this works with this simulator. Is almost 2 million voxels, but if we increase it to 28 million voxels, you can see that the shape of the wave, the behavior, the wave is in the same place, and it just adds much more detail. But overall, the simulator is doing the same thing, but with more resolution and with more detail now. So now you can see how raw and less detailed the left one is. Okay, so let me show you another scene. So here I've set up two simulators, so you can see that here I'm having a pure ocean wave, which is again quite tall, quite large. So let me show you the difference between different fluid freedom values. So on the left, the fluid freedom is 0, so the fluid is trying to exactly match the pure ocean. In the middle it's 0.9, and to the right we have fluid freedom of 1. So now here you can see that there are some splashes, the fluid is doing its own fluid thing, and it's creating some more interesting effects, but it's not following the ideal ocean wave that well. And also I have the same scene, but with a scale which is 4 times lower. So you can see that with a lower scene scale, so it's just the previous simulator was 100 meters tall, and this simulator is just 25 meters tall. So you can see that the pure ocean, the simulation with freedom of 0 matches the pure ocean very well, but when you start increasing the freedom, it has a lot of trouble moving all that liquid up. So the gravity pulls on the waves stronger, and it does not allow them to raise that much. So having a larger scene scale is very important. Okay, and so one cool thing about the new massive wave force that we've added to the nightlies is that before, the wave force could only affect the liquid, and it could only affect the liquid below the initial Fillup level. But now, here you can specify any of the standard Phoenix channels. So in this simulation, you can affect the smoke. It also affects the foam, the splashes, or anything else that you can plug into all of the other Phoenix forces. So in this simulation, I've created a wave force that affects the Phoenix smoke. And so now you can see some waves which are made up of smoke. So let me just give it some more time. Alright, and here it is. So you can see the waves that are forming, and then they're starting to move, and they're creating these interesting smoke turbulences. So this was it for today. Thank you for watching, and see you next time.